So we're going to have a look at this photoelectric effect simulator. And what we have here is a plate of sodium metal. Over here, you can change the metal that you're aiming your beam of light at. And up here, we have a lamp, and you can vary the brightness. You can make it more dim, right? You can make it brighter. And you can also change the wavelength of the light that's emerging from that lamp. And right now we have 670 nanometers. That's down in like the red range, and it's at an intensity of 75%. And as you can see here, nothing is happening on the sodium metal. No electrons are being released. So we can put that intensity all the way up to 100%. Still nothing happens. We don't get any photoelectric effect whatsoever. Let's put the intensity down to like a 26%. And now I'm going to gradually lower the wavelength, which is actually increasing the energy of the photon. Photons with shorter wavelengths have more energy. So let's keep going, making them shorter, more powerful, shorter, more powerful. Let's keep that going. Shorter, more powerful. Keep going. Shorter, more powerful. Oh, and all of a sudden, we can see that some electrons are being released from the sodium plate, and they're just gradually, kind of floating across that vacuum gap between the two plates, and that's creating a little current down here. So what we have are electrons are being freed from the sodium side. They're being collected on the other side, and now we have a current flowing through. And as long as that light is incident on the plate, it's going to continue. If we were to make that incident beam of an even shorter wavelength, in other words, make the light more powerful, watch what happens to the electrons that are being released. And you can see now that they're coming off with more kinetic energy. They're going faster than they did before. Now, if we change the intensity, let's brighten this beam and put that all the way up to 100%. Let's not waste time. And that should give us a flurry of electrons being released, not just one or two at a time, but much more. And down here, you can see the current. That's a measure of how many electrons are flowing past a given point per second, right? So if we change the intensity, that will decrease the current. There we go, and you can see that it's decreased in proportion. So the big question that physicists were asking themselves in the early 20th century is, why does this happen? Why does the intensity not trigger photoelectric effect, but the wavelength does?